Hello and welcome. My name is Kevin McCurr from BITanium Consulting. Finding the single source of truth has plagued data specialists for years and still does today. Whether it's for revenue reporting or accounting or gaining the single view of a customer, the challenge of consolidating data from multiple sources is significant. That is if you don't have data virtualization. Instead of gathering all the relevant data and storing it centrally, data virtualization does the exact opposite. The data stays where it is, and we consolidate a virtual representation of the data. Today, we are investigating how the Johannesburg Stock Exchange uses data virtualization to gain a single source of truth to verify billions of dollars in trades every day. A household name in South Africa, the JSE is the heartbeat of the South African economy, and we are thrilled to welcome Chester Enslin to share his knowledge and experience with us today. Chester is the head of enterprise integration, software and quality assurance from the JSE. Chester, welcome and thank you.
Thank you, Kevin, for that introduction. I hope to give you a bit of a glimpse into how the JSE is using Denodo in its operations on a daily basis. But before we get there, I thought I'd give you a little bit of background about the Johannesburg Stock Exchange. The Johannesburg Stock Exchange is an exchange like most of the other exchanges in the world which operate several markets. As you can see in this diagram on the left-hand side, we are operating 7 markets at the Johannesburg Stock Exchange. Now, that's the typical Wall Street that is seen on TV and in YouTube videos and things, where you will notice share prices flying up and down and traders standing on the floor screaming at each other, buy, sell, buy, sell. That is the typical activity that will happen in a market, except that most of it's done in the online world nowadays. The difference with the JSE is that we offer something called post-trade, where the trades are done within the various capital markets, and then settlement happens after that. And that's an entire business on its own, and something that we offer as an end-to-end solution from our exchange. Generally, exchanges in the world don't offer that type of functionality, and they will offer the different markets that you can trade on, but the settlement part of the business is usually offset to other institutions or conglomerates of banks that get together to try and work out what the net position is of a particular trader in order to figure out what monies need to transfer from one account to the other. I think one of the notable things about the JSE as well is the fact that we operate the government bond market, whereby we host an on-screen trading facility for traders to buy South African government bonds, and that information is visible and available to anyone who is interested. It's very important from an economic perspective, because then trust is instilled in the South African government, in the sense that the bonds that are offered by the institution are clear and everybody knows exactly what margin is going to be declared on those bonds, etc., etc. Rather than in some countries where government bonds are traded off screen and we all kept in the dark as to what is happening with those particular shares. So I think it's quite an important aspect of what the exchange does in the context of the South African economy. Post-trade is quite a big component of what we offer. And if you think about it, a trader like JP Morgan would be trading across several markets throughout the day and trading enormous values on some of the trades, which could result in a payment being or needing to be done for about $20 billion. In that case, they might then need to offset that against someone that's trading against their stocks, for example, a Citibank, and that could end up resulting in Citibank owing them $15 billion. So the net result is that $5 billion needs to be transferred from one account to the other. And we've got to work out that position throughout the day as an institution to ensure that we can guarantee that settlement when it comes to the end of the day. Otherwise, we might have a situation where the trader can't pay. And you can just imagine the devastating consequences that would happen were we not able to do so. So it's a very important aspect of what we do and what adds to the complexity of our trading environment. So to give some context about this operation, this post-trade operation of the JSE, I've created a little slide which shows the various systems that are in effect at the JSE, and I'm going to try and describe how they interact with one another. So as you can see on this particular slide, we've got a number of systems, and I'm not representing all of them. As indicated above, there's 194 different systems at the JSE. We operate the capital markets in several systems on the left-hand side. So if you can focus your attention to Millennium as one of the technologies that we use, Millennium is a capital markets platform that is used for trading purposes, and is obviously very robust, very high speed, and offers world-class standards in terms of order matching. We also have something that is offered by MTS, which is also owned by the London Stock Exchange, and this is where the government bonds will trade in. And then if you focus your attention on the bottom right to NASDAQ, we offer or use a solution called RTC, which is offered by NASDAQ, which is the clearing platform that we use at the exchange to make sure that all of these trades that are flowing out of Millennium and MTS are settled within the real-time clearing solution. And that's where we work out what the trader's position is, how much money he owes, and whether he's going to be able to settle those amounts at the end of the day. This information it's quite large. It happens very, very quickly. To just give you an idea, the order matching or the order response times on the Millennium platform is under 60 microseconds. And if you think about a millisecond, you can understand a microsecond is 1,000th of that. So it's pretty fast in terms of its response, and is definitely up there in the world league. So this picture gives you a view of the integrated nature of our exchange and the amount of data that needs to flow from one system to the other in a continuous manner throughout the day. So it's a real-time environment with very, very little batch processing that happens. Batch processing really happens towards the end of the day, and that's to clean up the systems, etc. Now, what we've done is we've used Denodo to provide a virtualized view of this information as it flows from one business unit to another business unit, and enables us to have a single version of what is happening in the environment at any point in time, which is a significant advantage for our business, and obviously something that is very necessary for us to ensure that we are 100% accurate 100% of the time. Without going into all the details, you can just imagine if we had uploaded an incorrect share price for something that is trading in an equity market on Millennium, we could have set, for example, the mid price incorrectly, and a huge trade could have gone through that system and resulted in a settlement value or a deal flowing down into the real-time clearing solution, which was enormous and would set the whole market out at the end of the day. So for us, accuracy is extremely important. Moving on to the data integration and how we've managed to use Denodo to solve some of our problems. What I'm doing here is representing a small piece of the application landscape at the JSE. There are 128 applications, but all of them need to operate in perfect harmony and be 100% accurate all of the time to ensure that there is a guaranteed settlement, and that the market that is using our particular exchange have a lot of confidence in our ability to make sure we can settle at the end of the day. So if we just want to focus a little bit in the third row, you will notice that there are several master data systems. One of the master data systems is holding the reference data for the equity shares. Now, equity shares are the typical shares that most of us know. For example, the Apple share or the Google share, whatever it is. In South Africa, we have quite a few of our own particular shares, but you would be able to trade on that share on a daily basis. And that share needs to be made available to the rest of the landscape, and everybody has to be aligned perfectly all the time in order to make sure that we balance correctly. So if you look at what we need to do, and this is just focusing really on the trading and clearing platforms, we need to make sure that the reference data ends up in the trading platform. So this would be the BITanium system, and that the same share information ends up in the clearing platforms on the other side, which is two clearing systems that we use to settle the equity market. Now, where the complexity starts to jump in is you will see here reference data for the equity derivative and currency derivative markets sitting in another master data system. And this same information needs to flow into the single trading platform, the Millennium trading platform, but the reference data needs to be present in a different clearing system. And this adds a lot of complexity to the way that we handle the data at the exchange, because you could extrapolate the example across this entire picture and imagine the different versions and different variations of reference data that needs to be sent from the source systems into the target systems throughout the day, at the start of the day and at the end of the day. So that complexity is what we needed to solve, and we used Denodo to achieve that. When developers develop software, they will often apply their own interpretations to reference data, and what might seem like a simple little change or simple little interpretation could result in devastating consequences for a market should that simple little interpretation result in the wrong share price, or an incorrect value being calculated, or the closing balance being incorrect, etc., etc. It's quite a worry for us, and we've needed to solve that particular problem through Denodo. So jumping into an example of what is the one truth that I've been talking about. You all know Apple. I think most of you know Apple, and there is something in the exchange world which is relevant to all exchanges, and that's called the alpha code. An alpha code will identify an instrument for you so that all systems that are connecting and operating in a market are able to uniquely identify the particular share. In the case of Apple, the alpha code is AAPL, and you would be able to trade on AAPL on NASDAQ or in the New York Stock Exchange, or even on some of the European exchanges, because you might be trading a derivative on AAPL. And the issue comes in when you look at alpha code as represented on other systems. In this example I'm providing to you, the bottom left AAPL is precisely the same font, same size, and the same wording as what the original was in the master data system. But you see in the other examples there are some slight variations, and funny enough, even on the last one, completely wrong, because AAPL and APL are definitely not the same. And these variations might seem innocuous and not cause damage, but when we are talking in the world of trading, the fact that you might have missed a cent on a mid price for an instrument will have very, very big consequences in terms of the financials of an institution, as well as the perception of that share value when we close the share off at the end of the day and publish its closing price to the market. Because you can imagine the volume that is traded, and if you're a few cents out on that midpoint, it could really change the value of that share. And both the shareholders as well as the market would be terribly unhappy with such an occurrence. And we did have it a few times at the exchange, and hence the reason why we had quite an issue in terms of which is the single version of the truth, and how do we make sure that everybody gets only that version of the truth and doesn't apply their own logic or their own interpretation to that. So what we did is we introduced Denodo, and we've got something called temporal version logic, whereby we represent the alpha code AAPL to all target systems from the source system, and that is the only version of the alpha code that you should be using within your particular system. And obviously it has to take all of the nuances and differences amongst all of these consumer systems into account to ensure that there's consistency across the landscape. So a complex problem to solve, but something that we've managed to do with Denodo. So this takes me into the architectural view of our implementation of Denodo. I'm sure many of you are very familiar with this, but I will briefly take you through this diagram to give you an idea of what we've done at the exchange. If we look at the bottom, we've got 194 data sources or data adapters that we've needed to put in place. And I'm sure many of you are very familiar with traditional database access. We're using Oracle, SQL, and some Mongo databases on the bottom left. But there are various sources of information that we gather as an exchange. And one of the big ones that we need to get information out of is the streaming service, which you can see there at the bottom. Both the MIT and RTC systems need to provide us with streaming data throughout the day in order for us to calculate the post-trade position of a particular share or that of a broker. So this data is transmitted into the Denodo environment very quickly throughout the day, and it's obviously millions and millions of transactions that come through that particular streaming service. And we then compile all of that information into base views. And as you can see there, we've got 1,746 base views that we have created, which sit on top of all of these data sources that we connect to in the Denodo environment. Then what we do is we connect, combine, and derive information from this, and we produce derived and interface views from all of these data sources. As you can see there, we've got 2,164 derived views and 541 interface views. And all of this is then combined into our 44 canonical models. So a canonical model being the ultimate entity representation available to the rest of the institution. We have 44 of them. And these models are what the consumer systems use in order to carry on with their particular part of the business. And you'll see in our implementation, because it's a real-time implementation, in other words, it's operational throughout the day, and there's millions of transactions flowing through these particular services on an hourly basis. We have two instances, so we have a primary and a secondary instance of Denodo running, and the source systems will then either receive transmissions of those data or they will query it themselves so that they can start working out the collateral position, the settlement values, etc., that's needed as part of the post-trade function of the JSE. The other thing that we also provide is a ability for users to log in and query the data themselves. So that's the query service on the right-hand side. And what is very nice about this implementation is the fact that we do not disturb the operations of our low latency solutions. So for example, that stream service that's sitting on the bottom is extremely latency sensitive, and we can't have a situation where additional systems or downstream systems are needing to access information and will cause a degradation in terms of performance. It's a big no-no in the exchange world, and that's where we would host things like Millennium and RTC. But through using Denodo, we've been able to get that information into a virtualized layer and represent it back to the consumer systems without disturbing the performance of those particular systems. I mean, as an example I've just given you, where we're concerned about latencies in the microseconds, where traders are wanting to get those responses for the high frequency trading. And then as a final parting point for you guys to see, one of the canonical models has a join to 45 data sources. So that's the instrument model, where you can access information about an instrument, and it has 321 fields that are available for consumption by the consumer systems. And we process about 2 billion rows a month that we send through this particular environment and make it available for all of the downstream systems. So I hope that gives you a bit of a view of the JSE and the implementation of Denodo and how we've managed to make it work for us.
Yeah, thanks, Chester. That was a fascinating narrative and journey I happen to know that the JSE was Denodo's very first customer in Africa, and our relationship goes back to 2012. And in that time, since the Denodo platform has been in place, there hasn't been one single error in the trades. So you mentioned earlier 100% accuracy, 100% of the time, and we can now add 100% track record. So again, well done, and thank you. A super interesting story. Thank you.
Pleasure.